All right, so let's go ahead and take a look at this example now, guys. In this case, it says we have an expression which is 5 times 2t, and it's giving us, in this case, the number of leaves in a plant as a function of the number of weeks since it was planted. Question in this case, guys, is what does each of the numbers and variables represent in the equation? Now, whenever we're identifying what we're looking for, we're actually looking first for an initial value or starting point, and then we're also looking for a common ratio. And we do want to go ahead and also identify what the variable in this case represents. So I'll just go ahead and put variable down here. And we'll go ahead and be working on these one by one. So starting off in this case, guys, with the initial value, I'm sure that just by looking at the equation, you could identify what the initial value is. But if we're not sure about that in this case, guys, we could make, in this case, the x here equal to a 0. And this will help us identify what the initial value is. So by doing that, if I do 5 times t, not t, sorry. 5 in this case times 2 to the 0 power. We know anything to the 0 power just becomes a 1. So our initial value in this case represents 5. Which, it's pretty simple. It's given to us. I know that's going to be a 5. But the question is, in this case, what does that 5 represent? What is it representing? So if I actually take a look back at the word problem, we're given this here. It says we have the number of leaves as a function of the numbers of the weeks, in this case, that's been planted. So if you guys recall from when we started seeing word problems, the phrase as a function of actually helps you identify which one is representing X, which one's representing Y. In this case, we're saying that X is actually representing the number of weeks, in this case, that have passed since it's been planted. And in this case, Y represents the number of leaves in the plant. Now, if you notice in this case, when we did that basic substitution of substituting an X value into the equation, we were actually looking for a certain Y value. So that 5 is actually representing the number of leaves. 5 is the number of leaves in a plant. That's what it's representing. So aside from it being the initial value, the 5 represents number of leaves once again in the plant. Now let's go ahead and take a look at the common ratio here. Now if we're we're starting off once again with nothing, I know we're going to start off at 5, but in this case, let's say a week has gone by, and now this becomes, so let's say this is week 1. A week has gone by, and now we have 5 times 2 to the first power. All right. And then let's say week 2 goes by, and now we have 5 times 2 to the second power. Week 3, in this case, becomes 5 times 2 to the third power. And in this case, we're actually seeing that pattern here. We're seeing in this case that starting off week 1, 2, and 3, and if I actually multiply these out, it's actually increasing. In this case, we could probably say that it's doubling in this case. So we want to go ahead and check in this case. Let's just actually find those solutions. This one here would give me a 10. This here, 2 squared is 4. 4 times 5 is 20. 2 to the third is 8. 8 times 5 is 40. Notice in this case, it's doubling, and it's doubling, and it's doubling. So in this case, the 2 is actually representing the common ratio. And it's representing, in this case, the number of leaves that is going to be, in this case, multiplied with our expression, or in this case, that's being multiplied each week. Multiplied each week in this case for us. So, once again, that 2, let's go ahead and write it here. That 2 is, in this case, representing the number of leaves. Let me actually put is the number of leaves multiplied by, no, not by, each week. So we know it's going to be multiplied by 2 each week in this case. So that's what the 2 is representing. It's the rate. Now, if we take a look at the variable here, we do have the variable of t. And t in this case, like I said, guys, we have x and y. T is going to be representing the number of weeks. So t in this case equals the number of weeks, or is the number of weeks. All right, and you're actually going to be given problems like this where they're going to ask you, you know, what does a 5 represent? What does a 2 represent? So you do need to know in this case, guys. I mean, looking at the word problem, we could probably use the structure once again as a function of to help you identify which one's x, which one's y. So yeah, that's example number 3. Let's go ahead and take a look at the next one. And here we have example 4. In this case, it says that Lucy is writing a novel. It says she earns $46,000 for the first book, and her cumulative earnings triple with each novel she's writing. So she's got a deal. She's getting paid for her first book, and it says that her earnings are going to triple, in this case triple, based on how many books she writes. So after each book, in this case, she's going to be getting triple the money of what she's already earning. Now, in this case, it says write a function. So we have to write an equation, write a function that gives Lucy's cumulative earning. And we'll go ahead and represent that with E of N in dollars when she has written N novels. Now, we don't know how many novels she's written, but we want to go ahead and build an equation in this case that represents how much she'll be earning if she writes another novel, if she writes, I don't know, maybe a lot of more novels. We'll see here. So starting off in this case, once again, let's go ahead and start off with our initial value. And our initial value in this case, guys, is going to be $46,000. Now, that actually sounds pretty good, you know, for a book. There's a lot of dedication put into that. So I'm sure they could probably get paid more, but, you know, we'll say $46,000, right? Now, in this case, they're telling us how much she's going to get paid more. They're not giving us an actual percent, but in this case, I could say that my common ratio here, is going to be 3. Common ratio is going to be 3 because in this case, it says that her earnings are going to triple. So whatever she has now, it's going to actually be multiplied by 3 times each time she makes a book. So that's actually the rate at how much it's increasing per book. So we're going to go ahead and say that 3 is the common ratio. And once again, in this case, the variable that we're going to go ahead and use, the variable here, is going to be N. And in this case, N is representing the novels, right? Novels she's writing. So let's go ahead and build an equation here. I have E of N equals my starting, which is $46,000 times the triple, which is 3 times of whatever books she writes. So that's